Thank you for the introduction. My name is Farkas, and I'm the co-founder and CEO of FerretDB. Who's heard of FerretDB before? Okay, quite a lot of people. Oh, look at that, some familiar faces as well. Well, thanks for coming. So, for those of you who haven't heard about it, don't worry, this is not a sales pitch. I'm not selling anything, another familiar face there. What I'm going to talk about is a little bit of database history and a little bit of, historical context to what is happening right now on the database market. Now, this is, of course, not a concrete historical overview. This is just a quick recap on the history of SQL and how it relates to what is happening nowadays with MongoDB. So I'm assuming that most of you are Postgres users, right? Hands up if you are. Yeah, most of you. Any MongoDB users? Okay. Well, so we found that there is a significant overlap between those who have to use MongoDB and those who use Postgres, so that's part of the story here. So the agenda for today, why do we care? Why do we move MongoDB to Postgres? A little bit of information on MongoDB's licensing, the thing I talked about, history of SQL as an open standard, whether we should make MongoDB an open standard, the architecture of FerretDB, just for those who've been wondering how does that work, and then a conclusion. So let's not talk about FerretDB or Postgres or anything else. Let's talk about the users. So this is the Stack Exchange Developers Survey of 2024. And if you take a look at this nice graph here, developers were asked, which database environments have you done extensive development work in over the past year, and which do you want to work with over the next year? And it had 76K responses, and of course, to nobody's surprise, Postgres finally took over MySQL as one of the most popular databases out there. And as we can see, it is something which developers desire. Maybe they don't use it today, but they want to become users in the next year or so. The second one is still MySQL, and then there's SQLite, MongoDB, and Microsoft SQL Server. There is an outlier on this graph, and I wanted to ask you if you have ideas on which database is the outlier. Well, I mean, of course, it's MongoDB, so this was not a big mystery. Yes, it's MongoDB, but why? So the reason why MongoDB is an outlier is because, first of all, it's the only document database out there. So if you think about it, for relational database users, we have Postgres, we have MySQL, we have SQLite, all open source. Some of them are a bit closer to Oracle than we would like, but still, these are open source solutions. And there is, of course, Microsoft SQL Server. You would say that's an outlier as well, but only because it's not open source. But the real outlier here, or the reason why this is considered an outlier, at least by me, is because MongoDB is the only document database solution. It's the most popular document database software, and it's also proprietary. So when you compare the opportunities of relational database users, there are plenty, and there are really mature solutions out there. But for document database workloads, there is MongoDB, and that is not open source. So hands up if you thought MongoDB is open source. Yeah, so there are still some of you, and I'm here to deliver the sad news. So MongoDB is no longer open source. They moved to the SSPL license, this server-side public license, which is created by MongoDB Inc. It was used by other companies as well, like Elastic, and they moved back to open source. But SSPL was not an OSI-approved open source license. And the reason they did not approve the SSPL license is because it discriminates against users and use cases. So if you run MongoDB as a service, then you are required to either publish your own source code with an SSPL license or pay a license fee to MongoDB Inc. So they thought that this is going to be a great open source license. The OSI disagreed, and I think most of us disagreed. They still think that it is open source, as we've seen in a cease and desist letter they sent to us. So you can get more information on the SSPL license on ssplisbad.com. I still don't know who created that page. It was definitely not someone I know. But it's a pretty good explanation on why SSPL is bad for you. Okay, so Postgres users here, I know. So why don't you just use JSON? Obviously, Postgres supports document database workloads to a degree, and it works well. And if you have to supplement your relational workload with some kind of document JSON workload, then you can use JSON support, and probably you will do just fine. The problem here is that MongoDB is really not about being a document database per se. MongoDB is an integral part of several frameworks, such as JavaScript frameworks, where the developer really shouldn't know much about the database itself or the underlying structure or the database. They can just implement the whole thing on the application level. So you start your JavaScript framework, you write code, and basically your database structure, your database strategy will be decided on the application level and not on the database level. So it's about the developer experience, and it's very hard for DBAs to understand. It was hard for me to understand as well, but it's true. Developers do prefer knowing nothing about the database. That's the cold hard truth out there, which we need to understand to cater to developers. And MongoDB did a great job with doing that. So I think it's hopefully a bit more clear on why we care about MongoDB users and why we want to move them to Postgres. As a recap, because they got the rug pulled from under them with the SSPL license, and I will talk more about it later. So let's see the short story of SQL, and I promise that this is not going to be a highly accurate representation on what happened with the SQL standard. We only have a couple of minutes to discuss this, but I really wanted to put today's MongoDB situation with how SQL looked like historically and how it evolved into the open standard as it is today. So the short history of SQL, we had Edgar or Ted Codd, a researcher at IBM's Palo Alto lab, and he came up with the relational model. He was the one who basically gave us the first paper on the relational model, which enabled databases to scale beyond the tree structured databases they worked with at the time on very early computers. So Edgar Codd published a paper on the relational database theory, but he was also a mathematician. You tend to have to be a mathematician back then in order to do anything with computers. Nowadays, that's less of a problem. But the basic situation with the relational model was that the query language, which Mr. Codd imagined, was only something software developers or hardcore mathematicians understood. So you pretty much had to write a separate program to query anything out of the relational database. So the relational model itself provided a lot of improvement and a lot of great things, but it was hardly usable for developers. Let's think about MongoDB for a second and then continue. So how SQL came to be as a query language is that there were two individuals, Don Chamberlain and Ray Boyce, who worked alongside at IBM with Ted Codd, and they saw the problem of having something great as a technology, but at the same time being very much not accessible to developers or end users out there. So in the early 70s, they published a paper where they outlined this English language-like query language to query the relational database, what IBM experimented with. And this was a great success. So together, SQL and relational databases really brought this awesome era where smaller companies with no dedicated developers or even larger ones with no appetite to employ database theorists could actually use their software. So IBM came out with IBM DB2. There's an interesting thing here. So you had to buy, or you couldn't even buy it. You had to lease these washing machine-sized computers in order to use the relational database and SQL. So you had to lease somebody else's computer, and only then you could use the database software you really wanted to use, what you could use. Does this remind anybody, something we have, nowadays? It's interesting. I mean, this is the 70s, right? This is not today, but is it really history? So if you like SQL, you pretty much had to use IBM. And then, of course, users and developers decided that they really want to move forward with SQL. They really want to move forward with the relational model. And they came up with alternatives to IBM's DB2. So they implemented a relational database. They implemented the SQL query language, or at least something like the SQL language, and came out with different alternatives out there, like Informix, Sybase, or there was this very unknown-sounding company called Relational Software Systems, Inc., which later became Oracle. Now, this is a crazy, interesting story. So Oracle was actually one of the few companies who were seen as the savior of IBM users. They saved IBM users from the terrible vendor lock-in situation they were in. Oracle is so cool, right? Like, they are so nice. But back then, this was really something that users felt about Oracle, that you no longer have to deal with IBM, you no longer have to deal with their sales teams every year to renew their lease on your computer. Actually, Oracle made it possible for SQL and relational databases to run on ordinary computers, which anybody could buy, even smaller companies. IBM initially did not really cater to those users. So obviously, just to go back a little bit here, there is a problem with what happened here. And the problem is that many of these products were not implementations of a white paper. So they kind of implemented what they thought SQL should look like, but actually it behaved pretty differently across all of these different alternatives. So migration between Sybase and Informix, not from a technical perspective, but even from the perspective of internal know-how, was pretty difficult. But nevertheless, they provided an alternative to users. And then in 1986, 1987, SQL became an open standard, and how that happened is that all of these different vendors came together and recognizing the importance of having a standard, recognizing the importance to enable users to have options, because that's actually a good business idea, they created the SQL standard. And this is where I usually have some questions, like whether I think the SQL standard is something all of the relational products adhere to nowadays. Of course not. Of course there are differences. Of course they behave differently, but it's still a night and day difference compared to something which is not standardized. So, so all vendors who implemented the SQL standard were still proprietary, and they still meant a degree of vendor lock-in. And that's where we got to the point where open source projects and users of open source projects embraced the SQL standard and made SQL available to anyone. So that's when SQL really became powerful, where even a smaller company or students or someone who did not feel like licensing software or leasing machines could actually interact with a relational database and with SQL. And of course, there are hundreds of derivatives since then implementing kind of the same behavior. So this is a nice thing to know. I think history is definitely an important aspect when you make decisions on what to use, what to do, how to vote, and stuff like that. So we would think that this is something which was in the 70s, 80s, 90s, you know, times unfortunately long gone. But actually, something similar is happening to document database users out there. So let's look at MongoDB and figure out why is this idiot talking on a Postgres track about MongoDB. I hope it will make sense. So MongoDB had a pretty similar history as the SQL standard itself, or SQL itself. Even though it started as open source, they had pretty similar things to offer to developers. First of all, MongoDB wanted to make it even easier for users to use a database. SQL is so complicated. The relational databases are so complicated. If you want to make them scale, you have to make decisions like the schema or replication or what have you. With MongoDB, you don't have to care about any of those things. You don't need to be a DBA to run a database. That was the promise. And so they achieved market dominance in certain segments of the developer community. As I mentioned, the JavaScript community is very much into MongoDB. And after they pretty much used open source as a marketing strategy, and this is a quote from their CEO, they went proprietary in 2018 after capturing more than 20% of the document database market. So all in all, how they started, because they had open source in the 70s, open source was not really a thing, but when MongoDB started out, they had open source. They realized that in order to appeal to users, you have to start an open source project, build a business around it, and then, unfortunately, their strategy was to change the license. Not only that, but they also wanted to redefine the meaning of open source. So evil companies like AWS or Microsoft Azure or some others are trying to take our software, and this is the only reason why we want to make sure that we have this different license where there are certain limitations. Yes, in some sense, MongoDB was right to look for alternatives, to look for ways how to keep the hyperscalers from leveraging their software for free. They tended to do that back then. I'm not sure to what extent they do it now. But the SSPL license was not just something AWS needs to care about. It's also something users need to care about, because if you think about it, if you limit the amount of available providers, you also limit the amount of competition. You have only a couple service providers to provide a service for you. They have to pay license fees to MongoDB, meaning that there is not going to be competition between the providers, or much less so compared to the relational world. So this is a familiar slide as we talked about SQL alternatives, but it's kind of the same situation. It's just the same situation in a more modern age. So let's look at this. MongoDB came to the conclusion that they changed the license in 2018. It was no longer GPL, it was something else. And then those companies who provided MongoDB as a service or had anything to do with MongoDB started to look for alternatives. And the really large ones were able to build their own implementations, very similarly to how it happened with SQL and relational. So Oracle, I'm not sure if they are seeing the Lord and Savior of MongoDB users out there at this point. I think it's hard for them to have that as an image. But they definitely created their own MongoDB-compatible alternative based on Oracle. And then Microsoft Azure Cosmos DB for MongoDB, another MongoDB alternative built on Postgres. So they started turning Postgres into MongoDB after the license was changed. AWS Document DB, another capable alternative to MongoDB, and the less known, at least this part of the world, less known Gauss DB, which is, I think it's Huawei. In any case, these alternatives were implemented for the same reason as back then the alternatives to SQL supporting database alternatives were created, to provide options for users and to make sure that MongoDB is not able to kill competition totally. But the problem is the same. So if you take a look at all of these alternatives, all of them live on a specific cloud service. Oracle Cloud, Azure, AWS, Huawei's own cloud. It's all proprietary. They work in a similar way. Their feature set might be similar, but actually it's impossible to migrate between them because it is not following an open standard. So they have a vastly different feature set. Therefore, if you're a MongoDB user and you're happy about finding a MongoDB alternative out there, that doesn't mean that you really have a full-fledged alternative which would support all of the features out there you are used to as a developer. You can't just start coding blindly or to migrate your application because it's just not always possible. And the second problem with MongoDB alternatives is that for a MongoDB alternative, MongoDB sets the pace. So you can't really provide an alternative which is 100% compatible because it's a moving target. Who knows what feature is going to be deprecated in MongoDB? Who knows what feature they are going to come up with just to make sure that you are not going to be able to become compatible with that. There is a very interesting website, I hope I can show you, is Cosmos DB really MongoDB? Hopefully this is the domain. Yeah, so this is MongoDB's website. They actually created is Cosmos DB really MongoDB and is DocumentDB really MongoDB.com out there, just to showcase that there are failing tests and missing functionality in these alternatives. But actually, we registered is FerretDB really MongoDB early on, so you know, at least there's that. So who cares about 100% compatibility? They totally missed the point, and I think this is a marketing gimmick, because if you think about it, most users would not use all of the features. It's true for Postgres, it's true for MongoDB, it's true for anything else you're using, whether that's an OS or something else. So what we concluded with several vendors and users out there is that we are in need of an open standard which actually describes what document databases should be capable of, the feature set they should be having to be competitive with other solutions out there, and to make users able to migrate between different products, different derivatives of this open standard. That would be undeniably very good for users. And then what is FerretDB? That's one of the last parts of my presentation. So what did we do to make sure that there is some progress on making it possible for users to migrate from MongoDB to Postgres, pretty much? So we created FerretDB, which is a MongoDB compatibility layer. It's written in Go. It uses Postgres as the backend. It's usable anywhere you want because it's Apache 2.0 license. And initially, what we did is we created a very lightweight proxy which translated SQL queries into, translated the MongoDB via protocol into SQL queries. But at the end of the day, even if we leverage the JSON compatibility, that's going to be much slower than vanilla MongoDB. So of course, this was not a sustainable solution. We came out with our tech demo in 2021, and we wanted to show that it is, or it should be, at least possible to do that. So MongoDB compatibility in itself, as I explained, should not mean that it's 100% compatible or that it has the full feature set of MongoDB. What we want to do is to arrive on a base feature set which most MongoDB users can use, or most developers. They don't even have to be MongoDB users. Can develop against. This means that, for example, with FerretDB or most of the alternatives out there, you can actually start MongoDB's own tools, like MongoDB Compass, or tools you use for migration between two MongoDB databases, and they happily run with the alternatives out there, even though Postgres is the database in the backend. So all of the frameworks, all of the applications are possible to use. Let's look at the architecture, what we did to address this problem. So we thought that the main reason for MongoDB's adoption is user experience, that you just take the MongoDB driver, you compile it with your application, and then you don't have to care much about the database to a certain degree. The MongoDB drivers, as you can see on the chart here, are Apache 2.0 because there is a need for you to be able to distribute it with your software. So it can't be an SSPL license or a non-permissive license. So MongoDB drivers by MongoDB are still Apache 2.0. However, the engine itself, the MongoDB API and the WiredTiger database engine they're using are covered under the SSPL. So our concept is to keep the MongoDB drivers. They are fine as they are under Apache 2.0. And if you look at the bottom chart, we recreate the experience which the MongoDB drivers provide and get FerretDB to interface with the drivers, implementing the MongoDB wire protocol, which interfaces with Postgres. A very new change in how FerretDB operates is that we actually work together with Microsoft, who were kind enough to open source the engine of their own MongoDB alternative, Cosmos DB for MongoDB. So now FerretDB uses the same engine to implement, for example, BSON, MongoDB's BSON support in Postgres, enabling us to use the same data types as what MongoDB does under the hood, not having to work around these issues. So there is this interesting progress with getting MongoDB back to open source, moving towards a common standard by implementing alternatives based on the same engine. That means that the feature set is going to be very similar, the behavior is going to be very similar, and ultimately this is what we want to do. This is a slide which I use when I speak on events which are not very much focused on Postgres. So I think it's obvious for us why Postgres is the choice here as a backend. It's fully open source. There's a large community. We were really surprised how interested the community was to address this problem for MongoDB users, to enable Postgres to do more for beyond the usual user base. And of course, as even on today's session, there are quite a lot of users who use MongoDB and Postgres as their database solutions. The crazy thing about FerretDB is that since we rely on Postgres and the DocumentDB extension, we can turn any Postgres as a service provider into a MongoDB as a service provider. What this means for users is that compared to MongoDB solution, which only runs in a handful, like literally a handful of providers, now it is possible with FerretDB 2.0, which just got released yesterday as GA, to turn any Postgres solution, whether it's on-prem or a cloud-based solution, into a MongoDB-compatible database as a service, which is going to bring the price of running MongoDB applications down. So just some history here with FerretDB 1.x. So as I mentioned, we just created FerretDB in a matter of weeks. in 2021, and we published it on GitHub, and we got 6.5K stars in 3 days, which told us something about the interest from the user side to move from MongoDB. But it was really not a good solution. It was a proof of concept where we stored documents in index.jsonb columns. We fetched pretty much all of the requested documents with SQL from Postgres, and then we did the filtering on the FerretDB side, which is extremely slow, sometimes 100 times or more slow than MongoDB. So there were quite a lot of differences we had to make sure we find a workaround for. So for example, field order in BSON documents is significant, while this is absolutely not a thing in JSONB. So we had to work around these limitations, which further increase the overhead on the performance. As you know, BSON has more data types than JSON, so we do have data types in MongoDB which was not possible to be stored with the JSON functionality of Postgres. This was a further workaround we had to make sure we cover. So unfortunately, this further decreased performance. I'm not going to go into all of the details here, but probably the most interesting is how MongoDB behaves to anything else you've seen before. For example, these guys. So actually, applications do rely on this behavior. So if you are dead set on creating a MongoDB alternative out there, you can just say, hey, we can do this much better, or hey, this is just not right, or hey, I'm uncomfortable right here looking at the code I'm writing. But MongoDB applications do depend on this behavior, and therefore we have to make sure to implement support for all of these different behaviors. We even had to replicate bugs on the FerretDB side just to make sure that we behave the same way as MongoDB would. Of course, we achieved this extensive knowledge on how MongoDB behaves by running our own compatibility tests and the MongoDB API tester tests. And of course, lots of user feedback, lots and lots of user feedback. So after 3 years, about a year ago, we started working together with Microsoft, where we thought that we need to do better for users. They have a MongoDB alternative. We have a MongoDB alternative, an open source one as well. And the first step towards achieving some degree of standardization is to combine our products into one, and this became FerretDB 2.0. So we use a custom extension called DocumentDB by Microsoft. DocumentDB was released together with FerretDB 2.0 with an MIT license. This is not AWS DocumentDB. They have a crazy thing going on with the names out there. So first Microsoft was DocumentDB, then AWS became DocumentDB. Now Microsoft looks like decided to go back to DocumentDB. But this extension introduces lots of functionality, like the missing data types, to enable us to not use all of these workarounds, which enabled FerretDB 2.x to perform as well as MongoDB in certain use cases. In some other use cases, it's still slower, but this is something we are really comfortable with at this point. As I said, not all workloads are possible to migrate, but we're getting there. 2.0 GA is available since yesterday. If there are any maintainers of Linux distros out there, pretty much all of you dropped MongoDB when they moved to SSPL. Now we have an alternative for you. So what should we do? We have a public roadmap where you can, of course, after testing your own workload, you can suggest fixes. You can suggest new features, which may be available for you if you're a MongoDB user, but not yet supported with FerretDB. And we are regularly adding these suggestions to our roadmap. There is no other way to create meaningful compatibility than testing and evolving on our feature set. So, conclusion for today. As Postgres users and as Postgres and MongoDB users, I hope that my presentation enabled you to understand a bit more on why am I such an idiot to talk on a Postgres conference about MongoDB. We think that MongoDB is going to become the similar commodity as SQL. We believe that there are users out there who we can help with Postgres, users who are not Postgres users as we speak. I think that it is the Postgres community's interest as well to look at more workloads and enable more users to run Postgres. We do think that we lead the way with FerretDB to open up the document database market. We do believe that this is a great start in standardizing document databases. We are relying heavily on the Postgres community to make this happen. So we do have lots of contributors and lots of advisors, regular testers of FerretDB, or Microsoft even, who contributed this extension to the Postgres community. And we are always looking for more, of course. You can try FerretDB if you visit docs.ferretdb.io. We have a super simple Docker image you can run. It runs Postgres for you and FerretDB and with the extension installed, so you can use that to evaluate your MongoDB workloads against FerretDB. On our GitHub, everything is pretty much out in the open. So if you would like to make suggestions, if you would like to tell us that this is the worst idea you've ever heard and we should all rot in hell, you can do that as well. That's also feedback, and we got some feedback like that. And of course, please follow us on the Fediverse. There's our Tech Hub social link, and at ferretdb.com. With that, thank you, and let me know if there are any questions.
Yep. Thank you, thank you. All right, got any questions?
Just not in Hungarian, Robert.
What was it?
Just not in Hungarian.
Yeah, no. Can anyone hear me? Good? Okay. So we have recently had developers request DocumentDB with AWS for various reasons. But now we have a problem where we have people who don't know how to query MongoDB itself or DocumentDB, and then you have developers developing against that. So I guess my question for you is, does FerretDB let us, say if I'm a non-MongoDB user, somebody that's wanting to normally query the backend, is there a way to directly query the backend to go around FerretDB, or?
Yeah, so the question was whether it is possible to query the same database with MongoDB and with SQL, or with the MongoDB driver and with SQL. Yes, so it is entirely possible. What FerretDB allows you to do is you have a vanilla Postgres instance with the DocumentDB extension running, and you can interface with it the same way as you would. Yes. Yes, and then you can query the same database through your MongoDB application, through the MongoDB driver of your choice. That's something which lots of users are looking forward to.
Okay. Additional.
But I'll let somebody else go.
Other questions?
Okay. So what happens if MongoDB goes back to being open source? What happens to FerretDB?
So what happens if Oracle becomes open source? So I don't think that, maybe there is a certain degree of understanding that there is a database which is good for everything. There is a database which, in all cases, is the most optimal situation. And sometimes the Postgres community, also tends to give those vibes. And then the MySQL community, like, why would you use Postgres? And it's a big back and forth. Or NoSQL is going to kill SQL. I'm still waiting. It's not going to happen. What happens is that there are different flavors of open standards in the database world, and it's a good thing that there are certain specialized databases, there are certain databases you would never use, but there is some workload out there which is going to require vector databases, for example. So new kids around the block, slowly but steadily, they are going to be available in established older database projects, just like how Postgres developed JSON functionality. So, so I think that it's great to have innovation. If MongoDB goes back to open source, I do think that they have lots of things going for them. We are not here to kill MongoDB, even though they are sending us love letters with their legal team very, very frequently. We are not out there to make MongoDB bankrupt. What we want to do is to open up the document database market the same way as how SQL did. It's not just IBM today or IBM and Oracle. It's hundreds of different flavors, and I don't think that we should argue that these alternatives exist. Rather the opposite. We want to embrace these alternatives. We have this initiative called opendocdb.org. It's about the open standard I talked about. So we have a manifesto there, which is a lot like what I've been talking about today, about the open standard. We do have some great supporters already for this open standard. We think that all of the hyperscalers would be interested in such standard. And that is also to make sure that we open up the market and create more alternatives rather than being angry at MongoDB or be concerned about how open source they are. In fact, we did invite MongoDB to support this initiative. There was this VP screaming at me on a Zoom call. It was tough. It was definitely not pleasant, but we do hope that with time they will understand that it's good for them as well. And actually answering your question, I do hope that they will go back to open source, just like Elastic did.
Okay, additional questions? Yep.
Thank you. We're using a lot of MongoDB.
I'm sorry, I have a hard time hearing.
I'm sorry. So we're using a lot of MongoDB, like, multiple different versions, and it's a sort of situation like you were saying where the developers don't really want to know too much about the database. So that creates a weird situation, because how do you find someone to be the DBA when it's the kind of thing where there's no DBA for MongoDB? So I need some advice, if anybody can provide it, on like how to find someone to be a MongoDB DBA.
But, okay, so as I understand, your concern is being a DBA is something normal in the relational world, and the document database world, it's not really a thing. So first of all, if we bring Postgres workloads on MongoDB, sorry, no, that's like totally wrong. If we bring MongoDB workloads to Postgres, you mostly need a Postgres DBA in that situation, because what you will need to care about is how will your backups work, how will your security look like, how will your Postgres instances scale if the demand is higher, and so on and so on. Having MongoDB as one of the use cases for your database infrastructure will look like similarly as to how your other workloads would look like from the DBA standpoint. At least that would be my understanding. But even if this poses challenges, let's look at AI nowadays. I realized that some of my younger friends, family members, and even the older ones started to look for things on the internet through AI. So I would wager that Google search or searching on the internet is also on the way out. Like, there is an abstraction layer on top of an abstraction layer on top of an abstraction layer. MongoDB is one of these abstraction layers for developers to make sure they don't have to think about the database. That doesn't mean that the AI backend will not need people to run it, right? It's actually a huge undertaking to make that reliable. On the other hand, similar thing with Postgres taking on more workloads. It's going to be some additional thing a DBA will need to think about, whether that MongoDB workload on Postgres, and let me correct myself, at that point it would be a document database workload. It would be an unstructured data workload. Will not be called a MongoDB workload. Similarly, the vector databases of today will be just vector functionality in some mainstream database. So what I mean by that is, if you take a MongoDB or document database workload, 10 years from now, it will be a routine thing for a DBA to take care of, rather than having to learn something totally different, like how to administrate a MongoDB database backend. I hope no one will have to learn that, because the open standard will enable us to ignore exactly that. I hope I answered your question.
Okay. Anybody else before we go ahead and let Peter go? No? All right, if you would please give me one more round of applause for Peter for coming up. Thank you for
so much.